Okay, today we are going to be starting our unit on transformations on the coordinate plane. To get started today with today's lesson, you will need your transformation booklet, which should already be put together. You should have a table of contents so that you can kind of see what topics we're going to be covering. And then you should have the shell of your glossary, and we're going to be defining some of these words as we go through. So let's go ahead and get started by defining kind of the first four words we'll need to get started. You can go ahead and pause the video now so that you can get these four definitions copied down. You should be writing down the definition for image, isometry, pre-image, and reflection today. So go ahead and pause the video. Okay, now that you have those four definitions down, I'm just going to talk about them really briefly. So the starting point for each problem is going to be your pre-image. That's the original shape of the object before you've moved it around at all. It's the original position and the original shape. We call it the pre-image. Your final result, once you've done a transformation and moved it around, is going to be called the image, and it's your final placement on the coordinate plane, your final shape and position. A transformation that doesn't change the size or shape of the figure we call an isometry, or sometimes you'll hear it said isometric transformation, and that simply means that you've taken a figure, you've slid it around, you've flipped it over, maybe you've spun it, but it's still the same dimensions, it's still the same size. And what we're going to be focusing on today is an isometric transformation, and it's called a reflection. A reflection just takes a figure and flips it over. So it's going to look like a mirror image of itself, and we're flipping over a line. Today we're going to be flipping images over the x-axis and over the y-axis, and those we will call our lines of reflection. Okay, so go ahead and turn to page 2. Where we're going to start talking about reflections. You're going to need at least 3 different colors. You should use colored pencils for this, but I'm going to do my original problems in pencil, and then I'll use my blue and black pens to do the reflections. So my directions say, I'm going to zoom in a little bit, my directions say to graph the original coordinates. So to start that, I've been given this triangle MNP. And we name triangles by their vertices. So we have M is negative 8, 4. We have N at negative 3, 8, and P at negative 2, 2. And that's going to be our pre-image. So what you're going to do is start at the origin. If it helps you to plot points, if it helps you to write in the numbers, then you can do that. I'm just going to count. So I'm going to go to the left 8. 1, 2, 3, 4, 5, 6, 7, 8. And then up 1, 2, 3, 4. I'm going to place a point and then label that point with my M. Okay, now I'm going to go to N. I start back at my origin. I go to the left 3 and then up 1, 2, 3, 4, 5, 6, 7, 8. And I get the point N. And then my last point is point P. Back to the origin, to the left 2, and up 2, and label that point P. I'm now going to use a straight edge to connect these points and get myself a nice pre-image here. And remember, that is called the pre-image because it's our original figure. All right, so there's my pre-image. The next step in our directions, it says to graph it over the x-axis and the y-axis, and tells us to use different colors. Now, you may want to do this work in pencil originally and then just color over it with colored pencils. That way, if you make any sort of mistakes, you can go back and fix it. I'm going to show you there's a rule for this, and it is when you're reflecting over the x-axis, you're going to have a pre-image that's in an ordered pair xy. And when we transform that into an image, it is going to turn into x negative y. And what that means is, whatever your original y value is, you're going to change it to its opposite. The x value is going to stay the same. And I'll show you why that rule is what it is in just a moment. So the first point then The pre-image is negative 8, 4. When I reflect that, what we write is M prime with M and a little apostrophe. And that tells the person who's looking that this is an image. This is something that's not the original, not function, but the original image. So my X is going to be the same, so I've got negative 8. My Y was 4. It's now going to be negative 4 because I need the opposite of 4. So let's look at this point. If I plot the point negative 8, negative 4, just using my rule there, I'm starting at the origin, I'm going to the left 8, and then down 4. And that is M prime. Notice that what we've done is we've taken this single point, and it was 4 points above my x-axis. It's now 4 points below the x-axis. That's because I've taken that point and I've reflected it over to the other side of my coordinate plane. So it was in this quadrant 2, and now it's in quadrant 3. All right, so let's go ahead and continue on. We'll take our pre-image of n is negative 3, 8. And I'm going to put n prime. Again, my x value doesn't change because it's still going to be the same distance over, so my horizontal movement hasn't changed at all. My vertical movement is what's changing because I'm flipping over that x-axis. So I get negative 8 because the opposite of 8 is negative 8. So when I plot that, I'm going to the left 3, and I'm going down negative 1, negative 2, 3, 4, 5, 6, 7, and 8. I put a point and label it n prime. Okay, and then the last one is P, and I'm running out of room here, so you'll have to excuse me. The pre-image was negative 2, 2. The image is going to be P prime. My x value remains the same. My y value is going to flip to its opposite. So the opposite of 2 is negative 2. So I'm going to go to my origin, go to the left 2, and down 2, and that's P prime. Okay? When you connect these points, you should see a triangle that is the mirror image of its pre-image. So we've taken this triangle and flipped it over into the quadrant just below it. Okay, so that's the x-axis. I'm going to switch to my black pen to talk about the y-axis. I'm going to try and start a little bit higher here. So the rule for y-axis, now instead of flipping over this x-axis, I'm going to be flipping over this vertical number line here, which is our y-axis. So we're going back to our pre-image, and I'm flipping it over that y-axis. So we should expect it to land right here. The rule then is I'm going to go from a pre-image of xy, whatever that happens to be for the given point, to an image. This time I'm going to change my x value because this time the difference is going to be in my horizontal movement, but it's still going to be the same distance up. So my x value will be its opposite. My y value will remain the same. Okay? So I'm going to really quickly go through all of the rules and kind of show you how that rule is going to work here. And then once we've got our rules taken care of, I'll show you how you can kind of do this visually if you're not an algebraic rule kind of person. Okay, so when we reflect this over the y-axis, just using the rule, I'm going to have m double prime, and we're just going to put 2 little apostrophes. The reason for that is because we've already on this graph got an m prime. So that's going to stand for my x-axis reflection, and it's always going to be just whatever the first reflection is, or the first transformation. Your second transformation is an m double prime. If we were to do a third transformation here, we would put a third little apostrophe and call it triple prime. But our m double prime, now I'm changing my x value to its opposite. I'm just multiplying it by negative 1. So whatever it was before, it's going to be the opposite now. It was negative 8. The opposite is positive 8. My y's aren't changing. So it was 4. It's going to remain 4. For n double prime, I am changing negative 3 to its opposite, which is positive 3. My 8 does not change because that's the y value. And then for p double prime, My -2 is going to change to its opposite, which is +2, and then the y value does not change. So I'm going to show you how to do this kind of visually, and then we'll check it against the answers we got with our rules. So if you notice when we reflected over the x-axis here, this point P started out 2 points above the x-axis. It's now in the same position relative to the x-axis, except it's 2 points below. So it's still 2 points over, but instead of going 2 up, we went 2 down. The same happened with N. It's in the same line here, but instead of being 8 above, it's 8 below. Well, when we reflect over the y-axis, it's going to be the same thing. So if you don't remember the rule or you don't like the rule, then you can always just kind of do it visually. If this P starts out 2 points away from the y-axis here, then it's going to end up along the same line, but 2 points in the other direction, and that'll be P double prime. M started out 8 points to the left of the y-axis. It's going to be along that same line, but now it's going to be 1, 2, 3, 4, 5, 6, 7, 8 points to the right of that y-axis. So I have M double prime, and then N started out 3 points to the left, so I'm going to go 3 points to the right, and I get N double prime. And before I connect these, I'll show you that the points that we found when we used our rule exactly match up with where they ended up when we just did it visually. So if you look at M double prime, we expected it to be at 8, 4. It is in fact 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4. So it is where it's supposed to be. You can check N and P, they ended up in the right place as well. So it's kind of two different methods for doing the same thing. Whichever you prefer is absolutely fine. It's always good to know the rule, but if you can find your way to the right answer without knowing the official rule, that's okay too. So when I connect this, you end up with an image that is this pre-image reflected over that y-axis. So that's reflections on the coordinate plane over the x-axis and over the y-axis. You're now ready to start some examples on your own on page 3 and page 4. You may end the video now and go back and review anything you need to see again.